Here's another example of a hypothesis test for the proportion. A drug testing company provides a one-panel THC test for marijuana usage. Among 300 tested subjects, 9% of the tests were wrong, either a false positive or a false negative. Use a 0.05 significance level to test the claim that less than 10% of the test results are wrong. Okay, so let's note what we have here. We have a sample size, a sample size of 300. We have a sample proportion, p hat, of 9%, or written as a decimal, 0.09. And we're to use an alpha of 0.05. Okay, so we know from previous problems we're going to need x to enter in the calculator. So to find x, the actual number of tests that were wrong, we'll multiply our p hat, that sample proportion, times n, and that will give us the number that were actually wrong. So 0.09 times 300, and we get 27. So 27 of the tests were wrong. Okay, let's look at our original claim. Test the claim that less than 1% are wrong. So the proportion is less than, 10%, not 1, 10%. The competing claim will be that P is greater than or equal to 10% or 0.10. Okay, now we can get our null and alternate hypotheses. The null hypothesis, always the equal sign, P equal to 0.10. Alternate hypothesis. Okay, so the equality, condition of equality, is with the competing claim, so the original claim gives us our alternate hypothesis. And we see we have a left-tailed test, the arrows pointing to the left. Okay, the other items we will be collecting, we'll be calculating a critical value. The calculator will give us a test statistic and a p-value. We'll use that information in our decision diagram to make a decision. Okay, and we know we have a left-tailed test with an alpha of 0.05. Okay, so this area out here is 0.05, and we, of course, here's 0. We need our critical value associated with 0.05. So inverse norm, area to the left we have 0.05. The amount of area to the left is 0.05. Okay, so let's look on the calculator. Okay, we'll find that in our distributions. 0.05. And we get negative 1.6448. This is the one we typically see rounded to negative 1.645. And I'll change my color and put it up here. So our critical value is a z of negative 1.645. And of course we were expecting a negative z since we knew we had a left-tailed test. Okay, now we're ready to enter our data. Stat tests one proportion z test Okay, so our P sub 0 this time, associated with the null hypothesis, was 0.10, 10%. Our X that we calculated was 27. 27 of the tests were incorrect, and there were 300 subjects in our sample. We have a left-tailed test, so I'll tab to the left-tailed test, the arrow pointing to the left, and calculate. Okay, here is our test statistic, the z-score negative 0.57735, so that would round to negative 0.58, and then we have a p-value of 0.281851, rounding to 4 would be 0.2819. Here's our p-hat, that 9% we saw earlier, and the sample size of 300. Okay, so our test statistic was negative z equals, I like to put the z there, negative 0.58 with a p-value of 0.2819, 0.2819. Okay, so let me get those on the graph. Negative 0.58, well here's, forgot my negative sign, didn't I, down here. Negative 0.165, so negative 0.58 would maybe be, somewhere in here. And recall that the p-value is the area associated with my test statistic, so it's this area, all the way out to negative infinity. Okay, so first check is the traditional method. Is the test statistic in the critical region? No, it is not. Is the p-value less than alpha? No, it's much bigger than alpha. Alpha was 0.05, test statistic 0.2819. So both of those together indicate that we will fail to reject the null hypothesis. Okay, so we have everything now but our conclusion. So to get started on the conclusion, the first question is, does the original claim, which we need to address in the conclusion, does the original claim contain the condition of equality? No, it does not. Do we reject HO? No, we do not. So that tells us we begin with, there is insufficient evidence to support the claim that and then we just look back. What was that original claim? It said that less than 10% of the test results are wrong. Let's think about this. Why are we saying that? There's insufficient evidence to support the claim that less than 10% of the test results are wrong. Well, since the null hypothesis is not associated with the claim, and we failed to reject this, then we really don't have any evidence to support this. They're not representing the same thing. If we cannot reject this, then we don't have evidence to support the original claim. So that's kind of where that wording comes from, the thought process behind it. Okay, so we have all of our blanks filled in, we've got our nice decision diagram, and we've drawn our conclusion.